This maths summary is focused on multiplying decimals. Decimals are all about place value and having some numbers, whole numbers on one side of the decimal point and parts of a whole on the other side of the decimal point. Well, when we're adding decimals, we always keep that decimal point in position because it guides us where we put our numbers. When we're subtracting, we do exactly the same. We keep the decimal point in its position to help us. And when we're dividing, we even keep the decimal point there too. But multiplying is totally different. It actually complicates things by keeping the decimal point in its position. We're not sure sometimes where we put our numbers, which side of that decimal point they go. So an efficient strategy is to actually take the decimal point out and put it back in at the end. It looks like this. If I had a decimal of 16.4, multiplying by 3, I want to do this multiplication question as efficiently as possible. So what I do is I jump my decimal point to the right. I'm jumping it out. I move it over the last number there, which is 0.4, and then I've got a decimal-free number of 164. I can use that whole number now to multiply very easily. I could do it in 3 different ways even. I could use the break apart model, the area model, or the algorithm to solve it, because now I'm actually multiplying 2 whole numbers together. If I was using the break apart model, it would look like this. 164 times 3, because I'm not dealing with a decimal anymore, I'm dealing with a whole number. Well, I break that into 100 times 3, 60 times 3, and 4 times 3, and I get my answers. And when I add them back together, I get 492. But what I need to do now is put the decimal point back in. Well, because I jumped at one position out, I have to jump at one position back in. So it jumps back over one number and I get 49.2. Now I get the same answer every other time, whether I'm using area model or algorithm like this. I've used my area model to multiply my 100, my 60 and my 4 times 3. 3 times 100 is 300, 3 times 60 is 180, and 3 times 4 is 12. And when I add them together, I get 492. Well, I jumped it out one jump, one position. So I need to jump my decimal back in one position, and I get 49.2.
Every concept mastered builds confidence, and there are more than 200 steps just like this waiting on the My5 website. The link's below. Now let's finish strong.
Even an algorithm where I'm multiplying 3 times 4 is 12, bank the 10, 3 times 6 is 18, put down, adding one more, put down the 9 and bank the 10, and 3 times 1 is 3 and grab that extra one, 4, and put 492. After doing an algorithm, I still need to make sure I jump back that decimal point. So it jumps one position back in and it's 49.2 again. So whatever style, whatever model I choose to use, whether it's break apart, area or algorithm, after I've got my answer, I need to jump back in. Now this decimal only required us to jump one jump to get rid of that decimal point. But sometimes we have decimal places after the decimal point that's got more than one position, maybe 2 or 3. Well, we can do exactly the same. If it's got one jump, it becomes 764. 59.68, 2 jumps, and it became 5,968. But at the end of this question, I would have to jump my answer with 1 decimal jump back in. This one would need 2 decimal jumps back in because I jumped it out twice. I have to jump it back twice as well. This is a question that's got 6.13 times 7. Well, I'm going to jump it out 2 jumps, and at the end, after I work it all out and get my answer of 4,291, I jump it twice back in to get 42.91. If I jumped it out here, 1, 2, 3 jumps out, at the end, after I solve it, and I chose to use the algorithm in this situation, I got this large number, but I have to put my decimal point back in. So I jump 1, 2, 3 jumps back in, and I get 78.036. So after I jump it out, I solve my question and then I jump it back in again. If I jumped it out 1 jump, I have to jump it back in 1 jump. If I jumped it 2 jumps out, 2 jumps in. And it's interesting, even when we look at multiplying 2 decimals together, if you have to jump it out of 1 decimal, we only have to jump it back in. But if we jump it out of both of the decimals, we need to add how many jumps we did altogether and jump it back in that many times. So it's an interesting process. It's a more efficient way of doing things, and we can choose how we solve our multiplication then however we like.